Hello everyone, my name is Jordan Valentine, and I'm here with my teammates Darian Wong, Charleston Wong, and Everardo Roman Yanes. Together, we make up Team 24 for the ASU Electrical Engineering Senior Capstone Project. Our project is a portable, solar-powered energy station designed specifically for disaster relief and first responder operations. The idea behind it is simple but powerful. When disaster strikes, access to reliable electricity becomes one of the biggest challenges. Phones, tablets, radios, and other communication devices are critical for coordinating rescue and relief, but traditional power solutions are often too bulky, too slow, or just unavailable when they're needed most. That's where our project comes in. We're building a compact, innovative system that combines solar panels with smart battery technology to deliver dependable power in the field. Solar energy is one of the most accessible and sustainable resources available during emergencies, but conventional solar panels aren't practical for rapid deployment. They take up space, they're heavy, and they don't adapt to changing light conditions. Our system is designed to solve those problems. The scope of our project is focused on creating an all-in-one, portable unit that can be quickly deployed, easy to use, and efficient at capturing and storing solar energy. To achieve this, we built a custom PCB to intake all sensor data, with an Arduino Uno serving as the central controller. We use an MPPT solar charger to maximize the efficiency of charging our 18650 lithium battery cells. Light-dependent resistors allow us to track sunlight intensity, while small servo motors automatically adjust to solar panels to capture the strongest light throughout the day. Finally, all of these components are housed in a custom 3D printed enclosure, keeping the electronics and batteries together in one portable, durable package. Our objectives are to deliver a reliable power source that is lightweight, adaptable, and practical for real-world emergency use. Ultimately, we want to be able to provide first responders and disaster relief teams with a tool that makes energy accessible anytime, anywhere, and when it's needed most. That's a quick overview of who we are, what our project is about, the problem we're addressing, and the scope of our solution. I'll now hand it off to my teammate Darian to go into more detail about the design and the progress we've made so far.
In the course of summer, our team has developed the first version of the PCB board. A test circuit was designed and tested. The design is able to move the source based on the LDR reading. The demo will show you what does our circuit do. Okay, so this is our circuit. So first we have the Arduino Uno that is controlling 4 LDR streetlight dependent resistors. And this circuit here will connect LDRs to the servos right here. This right here is our buck converter, which will step down the voltage which is around 12.6 volts to around 9.8 volts, drop to around 5 volts, which is sufficient enough for Arduino Uno to power up. As shown in the demo, it shows that our current prototype can do what we want it to do. It serves its main purpose of moving the solar panels based on the light intensity received. With the initial version of the PCB board defined design, our team is currently on schedule. For the budget, it is close to $200, but we are finding cheaper alternatives or other ways to make the budget lower or in a way cut down our budget. To see how all of these come together, everyone will share the plan for our future works.
Something mentioned before about solar panels is that they are very big and bulky, so that's still something that we need to overcome in our design. We want it to fit something more like a backpack. We also don't want fixed solar panels. We want them to move so that we can track the sun in the sky. We use microcontrollers for that, and that's for optimal power collection. So other stuff that we still need to do is finalizing Arduino code and pin layout. We still need an overall mechanical design to encompass all components of the final product. That includes things like the Arduino code, Arduino circuit, mechanical design, and solar panels. We need an updated and centralized code that handles the main operation of the circuit. We also need a potential circuit design to be done that may help us improve our final build. We also need mechanical parts that aid the movement of servos and an updated version of the PCB design. I'll now pass it over to Charleston.
Picture this, a self-sustaining solar tracker that is able to track devices and fall easily for transport. It is lightweight, small, and perfect for emergency responders in tough conditions, such as disaster areas. This project will allow us to blend portability with solar tracking, which is something rare in compact energy solutions. It's also able to power phones, radios, and even small medical devices without the reliance on any power grids. We have made substantial progress on the project so far, and we are passionate to meet weekly to further refine the prototype that we currently have. Thanks for watching, and we look forward to continue sharing our progress with the teaching staff as time goes on. And this is Team 24 signing off.